Hey, what is up? It is Sunday, May 1st, 2022. Welcome to Coding with Shaft. I think I'm going to change the name of this channel to Shaft the Algo Man or something like that. I kind of like that name a little better. Coding with Shaft. There's a million Coding with someone else channels. But whatever gets you to remember who I am and subscribe to this channel and get some interesting content and feedback from my videos, that would be great. And please like this video, comment, and all that other stuff that you do when you show love to somebody on YouTube. Okay, great. So today it's the beginning of a new month. It's May. April came and went, and in May I am totally ready to talk about this new problem called degree of an array. Okay, degree of an array, problem 697 on Leetcode. It's got an even balance of likes, well, a little more likes than dislikes, but the number is closer from likes to dislikes, and I feel I know why. But anyway, it's closer than the other problems that we've done. So let's go over the problem statement. Given a non-empty array of non-negative integers nums, the degree of this array is defined as the maximum frequency of one of its elements. Your task is to find the smallest possible length of a contiguous subarray of nums that has the same degree as nums. Okay, continuous subarray of nums that has the same degree as nums. All right, what does that mean? So the statement itself seems a little convoluted at first, but reading the example should help suss it out a bit. So the nums array is 1, 2, 2, 3, 1. And the output is 2. No, how did they get 2 from that? So the input array has a degree of 2 because both elements 1 and 2 appear twice. Okay, so you have the degree of the array is, there could be multiple elements that have the highest degree, and the degree is defined by the frequency of occurrence of these elements. Okay, so 1 and 1 occur twice, 2 and 2 occur twice, 3 occurs once, so that's not an element of the highest degree. Now, of the subarrays that have the same degree, 1, 2, 2, 3, 1, 1, 2, 2, 3, 2, 2, 3, 1, 1, 2, 2, 2, 2, 3, and 2, 2. The shortest is length 2, so return 2. So this is where the complexity arises, right? Because we have any subarray that, and contiguous subarrays could include any subarray that has degree 2, right? So this entire thing, 1 to 1, has degree 2. This guy has degree 2. This subarray has degree 2. This subarray has degree 2. Okay, this should scream to you right off the bat that, you know, if you're doing an inefficient solution, you'll be counting every single subarray. So this is going to be complete n squared counting plus any internal processing you need to do to count for the degree. So it's going to be at least n squared. Okay. Now, and it's probably going to be, in this case, n cubed, because the runtime is going to be n cubed, because you're going to be needing to account for the degree if you do it like brute force. If you go through every single subarray and be like, okay, what's the degree, right, etc. You go through 1, you go through 1, 2, you go 1, 2, 2, 3, 4, and then let's say you get through this entire iteration, then you have to start again at 2, 2, 3, 4, and then you have to go again, then that's a whole separate number of iterations. You go to 2, 3, 4, and it's a subarray, and then you get a set, and you got to go through every iteration of each of these, and it becomes a lot of extra work. So what do we do? In these kinds of problems, we try to solve them using some kind of windowing solution. Okay, and that's, you know, sometimes you don't even need to do that. Sometimes there's a trick, and there's probably a trick in this problem which lets you do that, but here's a little bit of a spoiler. If you try to not do the windowing solution, if you try to do the brute force, this is going to fail with a time length exceeded error, right? And so if I just go to my previous runs of this, you'll see I'll have one of these from a long time ago, and that's where I actually, you know, tried to do this, and yeah, so you have this time length exceeded error. Okay, so we don't want to do that. Okay, so how can we do this more efficiently? So first thing that I felt like doing was counting the frequency of elements. Integer FOEQ equals new HashMap. Int max deg equals 0. Int shortest equals integer dot max value. Okay, so now short test. Okay, so these elements are these are going to be the elements that start off the array, right? So let's start off the count. So what we're going to do is now we're going to count the max degree. Okay, so and so this should be easy to do, right? And if you're running into like an interview situation or something like that, this is probably something you want to put in its own separate function, because counting frequency, it could be, right? Sometimes you can combine the counting of frequency of items in an array with the actual iteration, but if you're just doing the frequency, then you might as well put it in its own function to make everything cleaner. Okay, so basically I'm going to assume that you know how to count a frequency map. We've gone over that in previous videos. In this case, we're getting max deg. We're counting what max deg is. Max equals freq.get nums I and max deg. Okay, so this is just getting the maximum degree as we're counting the frequency, because we can do that all in one iteration. Okay, so now here comes the fun part. Okay, I know you like when I talk about that. We're going to iterate through this entire array. Okay, but what we're going to do is I'm not going to, as I was showing you before briefly, do an iteration where I'm recreating every single subarray. That's not necessary and that's wasteful. Okay, so what can we do? Okay, well, let's try something else. While now I'm going to just, again, I'm using a while loop here because it's easier for me to illustrate, I think, what I'm doing when I talked about windows before. So first, I'm going to create the start of each window. Okay, equals nums, right. So what do I mean the start of each window? I'll show you once I put this part of the code there. Max deg map contains key nums right. Okay, int deg_len equals new. So I'm right now, you'll see what I'm doing here. I'm creating I'm creating this map, and I'm creating the starting point, as I said, of the window, and that occurs whenever I iterate through the array and find that I found the max value, right? So if max deg equals frequency get nums dot right, and my windows function, my window map here, this max deg map is my window map. I could also call it window map. Window map is not populated, right? Then if my window map is not populated with the starting element, right? So for example, if we look at this example on the right, I have 1, I counted that, I found that as a max deg element, so I'm gonna create let's create curlies I'm gonna put a key for 1, and then I'm gonna put a key for 2, okay, and then the values are an array, right? So I'll explain what I'm doing in this array. But what I'm doing is whenever I find the starting point of this window, I put this, I put right, and right is the value that I'm at currently. So if I'm at, the first time I found the element 1, I was at 0, right? And my degree, which is the second element of this internal list, is going to be 0 at this point. Okay, the first time I found element 2 here, my starting point was 1, okay, and the degree is going to be 0 again, okay? So right is equal to 1 here, and okay, great. So now that that's done, right, now how do I've got the starting points, how do I determine the end points? So I'm gonna have to pretty much, for each iteration, for each key here, okay, for each key, I'm going to, and I could probably optimize this a bit, but for each key, I'm going to have to keep track of the length of the array. Okay, so the keys are the max degree elements. Get key. Okay, so now I'm keeping track of the degree, and I'm keeping track of the window length. Okay, that's this thing that I just put in here. This is essentially the start, the window length, and it's containing the degree up to the current point. What do I mean? I'll show you in a second. So deg len plus plus max deg map key deg len if deg len 1 equals max deg, then shortest equals min shortest right minus deg len 0. Okay, so this is where I guess the tricky part is coming in, and I'm gonna add 1 because I'll explain that as well. So this part here you should understand. This is just me pushing through every index of the array. Here, what I'm going to do is I'm going to create this window, okay? And don't get confused. The first element is the start of the window. Start, and this should be clear. The start is at 0 for 1, and the start is at 1 for 2, right? The second is current degree, okay? Current degree, okay, at the start. And the current degree is 0 at the start. And then as I go through the keys that exist, the current degree, and the reason we're recording this starting point is because later, whenever we find that the current degree equals the max degree, when current degree for a particular window equals max degree, then we check the shortest length, okay? Because at some point, current degree, when does current degree for this array equal max degree? What is max degree? Max degree is 2. Current degree, for the first iteration, current degree is equal to 0, and then we set it equal to 1, right? Then for the next iteration, current degree for 2 is equal to 1, we ignore 1. For the next iteration, current degree of 2 is equal to 2, so we already got current degree of 2, equal to the max degree, because max degree is 2. So we record that length, and the length of that array is 2. Shortest equals 2, right, at this point. And then the next iteration we have 3. 3 is not in the map, so we ignore it. In the final iteration we have 1 again, and the current degree for 1 is equal to 1, 0, 1, 2, 3, 4. So therefore, the length of this is going to be 4 minus whenever 1 occurred. So at the index 0, and that is equal to 4, making the shortest still equal to 2. Okay, you get that? I hope so, because this is, we are just keeping track of whenever the second element here hits our current degree, and then we subtract the current right value. So 4 in this case was the current right value from the starting point, right? And remember, the first element of this internal array is the start. So the start is here, 0, the end is here at 4. Okay, now let's try if this works. It's tricky, I know. It contains lay. That is not a word. And deadline. And oh yes, we need to return shortest, of course. Accepted. Run it. And bam. And see, there are faster solutions, but you know what? That's actually fast enough. You can see the progression of solutions that I've done over the time, getting faster and faster. And yeah, the space also, about the same, but we could reduce the space as well. We can optimize this internal part and make this a lot faster. And so this becomes, before it was an n cubed, this is approximately n squared. The thing is, I could probably make this even better than n squared by optimizing this internal loop, okay? But yeah, the reason why it's approximate also, it's not exactly, because this internal, it depends on the degree of the internal values, right? So it's greater than n, right? But depending on the degree, it can be less than n squared, because the degree, the largest degree is going to be, it's going to be, the largest degree is going to be proportional to the number of times we iterate internally, right? But then the largest degrees, larger the degree of it's the less elements that we're going to have to iterate through in the array. And if the degrees are all equal to 1, for instance, then we only iterate, that's the best case, we only iterate once through the entire array. Okay, so you see there's a little bit of tricky math probably behind that. So anyway, that's the solution to this. I hope you liked this problem. Not quite an easy problem, but yeah, I do appreciate you sitting with me through this, and thanks a lot. I'll see you next time.